In this video, we will be presenting the analysis and design of a gardening booking system as part of the COMPGC22 software engineering coursework. The group involved in this project is comprised of Chao-Wen Guo, Justin Moser, Ke Wei, Max Gander, and Sengji Li. So let's talk about the main idea behind this web application. We have designed a system that lets clients book gardening services from a website. To give an idea of the scope of our project, the clients in our system are UCL's facilities managers. These facilities managers are expected to log in to the booking system to make a booking. Once that is made, the system takes care of assigning gardeners to those requests, which we call jobs. Similar to the way user accounts are managed at UCL, the management of clients and gardeners is done by the admin account, which has its own set of interfaces. The rest of this presentation is focused on explaining the main requirements, use cases, and object-oriented design of the system. We will round it off with a run-through of the mockups and finally end with some concluding thoughts about our project. Let's talk about the main requirements. We needed to build a system which would allow clients to book a job for a particular location called a site for a specific time. The client determines the duration of the job, but it is the system that determines which gardeners are assigned to that job. In addition to notifying the gardeners via email that they have been assigned jobs, the system must also allow the gardener to view the jobs that they have been assigned to, and likewise for clients to view the jobs that they have requested. Once a job is complete, the system must allow clients to rate the quality of completed jobs. While the rating itself does not influence how gardeners are assigned to jobs, they do provide a feedback mechanism for admins to remove unsuitable gardeners from the booking system. This diagram shows the use cases where we have identified from our requirements and how they connect to the actors. The client is mainly interested in booking a job, and likewise, a gardener is able to use the system to mark a time off. And in addition, gardeners and clients will be able to view the jobs that are associated with them, whether they have assigned or requested them, in the form of a timetable or in the form of a jobs list. And finally, once a job is completed, the client will be able to rate the job that the gardener has done. So let's look into one of the main use cases, which is to book a job. The client first logs into the system and is shown a timetable of jobs that the client has booked. A successful login is a precondition of this use case. Client fills in a form in the sidebar and clicks Book. This form includes details about the time and location of the booking. The system finds the best combination of available gardeners for those times and assigns them the job or part of it. Gardeners assigned the job are notified by email, and finally the client is shown the updated timetable with the newly added job. In the case where the system is unable to find a suitable combination of gardeners for the job, the system will return with an error message to the client that no suitable gardeners were found. So let's take a quick look at the class diagram we have designed. At the very bottom, we have our model classes. The job represents a gardening job at a specific time for a fixed duration. So a booking request from the client for gardening services from 1 p.m. to 2 p.m. would actually be represented as two job objects within the system, each representing a 30-minute portion of the booking request. We have decided on this pattern because it would facilitate the assignment of gardeners by the system. Each job also has a site, a rating, a client, and a gardener associated with them. Clients and gardeners are a type of user. Clients and gardeners are modeled differently because they have different sets of data associated with them. On top of these model classes are their respective managers. These are responsible for manipulating the model objects according to the business logic. Finally, there are the controller classes which mainly deal with the web interface. For example, the accounts controller is responsible for the home view where the user can log in. With the class diagram in mind, let's take a look at an example of a sequence diagram that illustrates the interaction between the classes in the class diagram. We have chosen to elaborate on the task of removing a gardener from the system because of the complex interactions involved. When a gardener is removed, all future jobs associated with that gardener needs to be reassigned to other gardeners. So starting from the left, the admin will click a delete button on his admin dashboard to delete a particular user. The dashboard controller then relays this request to the user manager, which then gets the user record that is to be deleted from the system. The user manager will be able to determine that the user being deleted is a gardener and proceeds to call the job manager to get jobs by user. The job manager calls reassign gardeners to find out the future jobs of that gardener. The job manager also calls reassign gardeners on the future jobs of that gardener. The job manager would attempt to do that just like it would to schedule new jobs and notifies all new gardeners assigned with jobs. Finally, the job manager returns and the user manager can now proceed to delete the user from the system. The dashboard controller finally returns the dashboard view with the list of users updated to reflect the removal of the user from the system.
In our analysis and design stage, we created activity diagrams for the main use cases, showing the user journey through the system for each use case. Here we have an example of the activity diagram for the gardener cancelling a job and booking time off. As you can see, the system, once the user has selected a time slot to amend, checks if the time slot has a booking. If it does, it warns the user and on confirmation cancels that booking. If there is no booking, the time slot is marked as unavailable. State diagrams were also created as part of our analysis of the system design. Here is an example of the state diagram for the notification system. The system waits for the notification to be received, and once it is, the notification process is started. And when the notification type is identified, the system will send the relevant and corresponding email.
This diagram shows how the system will be deployed to production servers. It shows the logical separation between components in the system and also physical separation in terms of which type of servers the components will be deployed to. The presentation layer, consisting of the website and associated files, will be hosted on a web server. The business logic files, along with the services that expose the APIs created inside the business layer, will be hosted by an application server. Communication between the presentation layer and business layer will be done via HTTP request to the RESTful web services associated with the necessary parts of the business logic. This business layer includes the class representation of our model. The database will be hosted on a separate database server. Finally, the notification service will be hosted on a separate messaging server. The business layer will communicate with this layer using the message bus communication protocol and message queues. This will provide us with real-time functionality for notifications to users in the system.
And now for a run-through of our system using the mockups we have created. This is the login page. To get access to the system, the client must log in to the system by putting his or her username and password and press the login button. After logging in, the client will be directed to the main client page called the timetable view. On this page, the client can view all the jobs that have been placed by him. Each block on the calendar represents a job. Different colors are used to differentiate the jobs that relate to different sites. The client could use a form on the left side to create a job. He just needs to put in the site name, the time, and the date, as well as a short description of the job that needs to be done, after which he could click the button book and the job will be created. The client can choose to update existing jobs by clicking on the block on the calendar. A small window will be displayed and it contains the detailed information of the job as well as the information of the gardener assigned to that job. There are two buttons. One is the delete button, which would cancel the job. The system would eventually notify the gardener that a job is cancelled. If the client decides to change the description of the job, he can change the job description and click the update button. Additionally, the client can click view booked jobs and ratings. This would show the same jobs that the client has requested but is shown in a list instead of a timetable. Here, jobs that are completed can be rated. This is done by typing in the feedback and clicking the submit button on the job that is completed. The client can also search for all jobs or unrated jobs in order to trim down the list if the list has been too long. Likewise for the gardener, when he logs in, he will also see a timetable like the client. But this timetable contains not only the jobs that have been assigned to him, like the one shown here, but also the time offs that the gardener has booked. For example, like the dental appointment and graduation ceremony here. So in order to book a time off, the gardener will need to set the date and the time of the time off and a reason for that time off. This in the system will translate to a job as well, which will make the gardener unavailable. Now the gardener can also cancel jobs that are assigned to him. What he can do is to first click on the job that was assigned to him and click the cancel job button. Now this doesn't actually remove the job immediately from the system. The system will try to reassign the job to other gardeners before cancelling if there are no other gardeners found. Here in the details window, the gardener is able to see the site as well as the client and phone number of the client who requested for this job. Now let's look at the page that the admin sees when he logs in. He will be shown a dashboard, which is a list of sites and a list of users in that system. Using this page, he is able to edit or delete sites, edit or delete users, as well as add them. And so there you have it. It's a short run through of our mockups. Looking back at the system we have designed, we think our design largely conforms to the requirements that were set out. One aspect that wasn't met was the ability to allow users to register for accounts and manage their own passwords. Currently, the system requires an admin to do that. Otherwise, our system conforms to the requirements set out. In terms of expanding the project, we think this system could be further improved with smarter gardener assignments that take into consideration the location and workload constraints of a gardener. Additionally, jobs that could not be scheduled at the point of request could be put to a waiting list in case another job gets cancelled. Bookings could also be extended to the city itself rather than be limited to UCL, in which case jobs would also be billable by the system. This concludes our presentation for the gardening booking system. Thank you for your time.